Hello everyone, and welcome to our physics and mathematics session. Today, we're tackling a fundamental problem involving forces and friction, something you encounter everywhere, from walking to braking a car. Our problem states, a wooden block of mass 2 kilograms rests on a horizontal surface. The coefficient of static friction between the block and the surface is 0.4. A horizontal force is gradually applied to the block. What is the maximum static friction force that can act on the block? Let's break this down step by step. Step 1. Visualize with a diagram. Imagine a simple drawing. You'd have a rectangular block sitting on a flat, horizontal line representing the surface. On this block, we draw arrows for the forces. An arrow pointing straight down from the block's center. This is the force of gravity or the block's weight. An arrow pointing straight up from the surface to the block. This is the normal force, the support force from the surface. An arrow pointing horizontally to the right or left, representing the applied force. And finally, an arrow pointing horizontally in the opposite direction, opposing the applied force. This is the static friction force. Step 2. Identify key variables and constants. From the problem, we have the mass of the block, m, which is 2 kilograms. This tells us how much stuff the block is made of. The coefficient of static friction, μs, pronounced μs, which is 0.4. This dimensionless number quantifies how sticky the two surfaces are when they are not moving relative to each other. We'll also need the constant for acceleration due to gravity, g, which is approximately 9.8 meters per second squared on Earth. This helps us calculate the weight. Our goal is to find the maximum static friction force, which we'll call Fs max. Step 3. Write down relevant equations and principles. To solve this, we rely on a couple of key principles. 1. Newton's second law in the vertical direction. Since the block isn't accelerating up or down, the net vertical force is 0. This means the upward normal force, N, is equal in magnitude to the downward weight, W. 2. The formula for weight. W equals m times g. Weight is the force of gravity on an object. 3. The formula for maximum static friction. Fs max equals μs times n. This equation tells us the largest possible friction force that can exist before the block starts to slide. Step 4. Substitute and solve. Let's plug in our known values. First, calculate the weight W of the block. W equals m times g. 2 kilograms times 9.8 meters per second equals 19.6 newtons. Now, because the block is on a flat horizontal surface and not accelerating vertically, the normal force N is equal to the weight. N equals W equals 19.6 newtons. Finally, we can calculate the maximum static friction force, Fs max. Fs max equals μs times n equals 0.4 times 19.6 newtons equals 7.84 newtons. Step 5. Check your answer. Does 7.84 newtons make sense? The units are correct, newtons for force. The magnitude seems reasonable for a 2 kilogram object with a coefficient of 0.4. If we got a negative number, or a value wildly different from the weight, we'd know to recheck our calculations. This value indicates that a relatively small force is needed to overcome the static friction for this specific block and surface. Step 6. Conclusion and real-world application. So, the maximum static friction force that can act on the block is 7.84 newtons. This means that if you push the block with any horizontal force up to 7.84 newtons, the static friction force will match your push, and the block will remain stationary. But, as soon as your applied force slightly exceeds 7.84 newtons, the static friction will be overcome and the block will begin to move. Understanding static friction is crucial in many real-world scenarios. Think about how car tires grip the road, allowing you to accelerate or brake without skidding. Or how you can pick up objects without them slipping through your fingers. It's all about ensuring the applied force doesn't exceed that maximum static friction. Step 7. Additional insights. It's important to distinguish static friction from kinetic friction. Static friction prevents motion, while kinetic friction acts when an object is already moving. Typically, The coefficient of kinetic friction is smaller than the coefficient of static friction, which is why it often takes more force to start something moving than to keep it moving. Also, note that friction doesn't depend on the contact area, but rather on the normal force and the properties of the surfaces. Step 8. Final summary and key takeaways. In summary, to find the maximum static friction, we first calculated the weight, then determined the normal force, and finally used the coefficient of static friction to find the maximum resisting force. This problem beautifully illustrates the interplay of forces and Newton's laws in maintaining equilibrium, or predicting when it will be broken. It's a foundational concept in mechanics that helps us understand why objects stay put or when they'll finally budge. Thank you for joining this session. I hope this detailed breakdown was helpful. If you found this explanation useful, please give the video a like, subscribe to the channel for more physics and math content, and feel free to share it with anyone who might benefit. Leave your questions or comments below. I love to hear from you. And if you have a specific problem you'd like to see solved in a future video, consider donating to the channel. Each month, we'll pick a few viewer-requested problems to tackle. See you next time.